Hello, my name is Cristel Lyka Abalos from BSCE 4C. So today, the lesson is about PURLINS and I will be discussing some sample problems about collapse mechanism. So let's proceed to sample number 1. So determine the plastic limit or nominal distributed load Wn in terms of plastic or nominal moment, which is Mn developed at the hinges. So for the solution, so as you can see in the given figure, so meron tayong fixed support at both ends. And another one is meron tayong distributed load. So based on the principle na napag-aralan natin, kung natatandaan natin, kapag may fixed support tayo, meron siyang resisting moment. So therefore, kung ipa-plot natin siya sa collapse mechanism, meron siyang magiging plastic hinge dyan at both ends. So, and we also know na kapag may distributed load is meron siyang concentrated load at midspan. So therefore, magkakaroon tayo ng tatlong plastic hinges. So the joint A, B, and C are plastic hinges based sa ating pag-analyze sa given figure. So since we have concentrated load at midspan, so sa gitna, magkakaroon siya ng failure or deflection sa gitna. Na sinasabi nga sa principle na kapag plastic hinge is refers to the failure of the support. So due to the deflection, may mapo-form tayo na right triangle. So then if we have right triangle, meron tayong theta. And di ba sa part na ito ay magkakaroon or magiging L/2 siya. So dahil alam natin sa midspan nag-a-act yung concentrated load. So mahahati yung length niya. So by using trigonometry, tangent theta is equal to delta over L/2. So based sa small angle theory na napag-aralan natin, yung tangent theta kasi is also equal to theta itself. So theta lang. So pwede lang natin sabihin na theta na lang yan. And consider na ine-neglect na natin yung tangent based on the theory. So magiging theta is equal to delta divided by L/2 na lang siya. So by distributing, ang magiging deflection natin is delta is equal to L/2 times the theta natin. So based yun sa pag-a-analyze natin dun sa right triangle na. So next, we have the formula na external work is equal to internal work. So which is yung external work is the total external load times the deflection of the mechanism. So since ang total external load natin is Wn lang, then times yung length. So magiging external work is equal to Wn times yung length, then times natin yung nakuha nating deflection. So where the deflection na nakuha natin kanina is yung theta times natin yung L/2 by using small angle theory. So for distributed load, ang gagamitin nating deflection is kalahati lang. So multiply lang natin yung deflection natin sa 1/2. Pero kapag concentrated load ang gagamitin natin is yung full deflection. So therefore, we will be using the external work is equal to Wn times yung length, times natin yung 1/2 theta times L/2 since naka-distributed load yung ating given problem. So that is for our external work. So for the internal work naman, paano ba natin makukuha yung internal work? So sabi nga sa principle, internal work is the sum of the MN at each plastic hinge times the angle through which it works. So imumultiply lang daw natin yung MN kung ilan yung angle dun sa ating plastic hinge. So dito, meron tayong tatlong plastic hinge kung nakikita natin sa figure. So we have angle or theta at A. Meron din tayong theta at C and the 2 theta. So saan ba nakuha yung 2 theta na to? So di ba based sa geometry principle, kapag yung triangle kapag ganito yung triangle, yung angle at A at yung angle at C or yung angle natin at both sides ay equal lang sa angle na to. So, yung sum nilang dalawa is equal sa exterior angle natin na to, kaya siya naging 2 theta. So, therefore, our internal work is MN multiply natin sa sum of the angles. So magiging MN times sum of angles, which is the theta plus 2 theta plus again the theta. So next step is computing the external work and internal work. So since na-determine na kasi natin yung equation for external work and internal work, pwede na natin silang pag-equatein. So based sa ating formula, by multiplying the 1/2 to the L over 2, we will get 1/4. And on the other side naman, by distributing the MN to angles, we will have this equation. So by simplifying again the formula through algebra, we will get this final equation. So since binigay yung length sa problem, by substituting the length to the equation, we will be having the answer of for 18 feet span, the plastic limit distributed load is WN is equal to MN 16 over 18 squared. So we will get the final answer of, kapag sinimplify natin, WN is equal to 4 over 81 times the MN. So that is the final answer, and that's all for the sample problem number 1. So let's move on to problem number 2 for the collapse mechanism. So the problem is determine the plastic moment MT using the virtual work method and the uniformly distributed load WU. So use W18 by 35 A992 steel where yung Fy niya is equal to 345 MPa and Zx is equal to 1090 times 10 raised to 3. So as you can see, this is the illustration of our given problem. So halos same lang siya sa previous problem natin. However, it is said that we will be using W18 by 35 A992 steel and also given natin yung kanyang mga properties like Fy and Zx. So the beam has fixed support. So meaning sa collapse mechanism niya is may plastic hinges tayo on both ends. So another one is the deflection of the beam that is also led to plastic hinges. So due to the concentrated load is equal to 20 kilonewton, nag-a-act siya sa gitna kasi concentrated load. So here we will be having another plastic hinges. And also, the length of the beam is given, which is 5 meters plus 5 meters is equal to 10 meters. So, due to the deflection, may mapo-form na ulit tayong right triangle. So, then if we have the right triangle, meron tayong theta. So, the height of the deflection here will be delta. So, which is yung na-discuss natin before. So, then bakit na nga naging 2 theta yung part na to? So, as I said before, based on the angle theory, this is 2 theta is also equal to the theta of both sides. So, angle at A at angle at C is this angle, the 2 theta. So, yung angle at A at angle at C is equivalent lang dito sa angle na to. So, let's proceed to the solution for this problem. So, external work done is equal to internal work done. So, P, which is yung concentrated load natin, times 5 theta is equal to MP theta plus 2 theta plus theta. So, P is the concentrated load nga, given in the figure. Saan natin nakuha yung 5 theta? Di ba ang equivalent ng ating delta or yung deflection natin is by trigonometry is L over 2 times theta, which is the length is equal to 10 meters divided by 2 lang kasi L over 2. So, kasi ang formula kapag, di ba, pag triangle is 1/2 base times height. So, sinimplify lang natin siya. So, we have 5 theta. So, for the internal work done naman, we have Mn times theta plus 2 theta plus theta. So, this formula is na-derive natin from the given figure. So, we have given 3 theta kasi. Since wala tayong presence ng real hinge dito, so, for example, at joint C, we have a real hinge, or meaning hindi siya nagre-resist ng moment. So, therefore, hindi natin isasama yung given angle niya into our solution. So, but in the problem, we have fixed support at both ends. So, automatically, kailangan natin yung angle niya. So, because internal work done is the sum of the plastic hinge. So, take note, it is plastic hinge. So, times natin the angle kung saan siya nagwo-work or nag-a-act. So, getting back in the solution, so we will be having this final equation by simplifying it. So, we will get the value of Mn is equal to Mp, which is 25 kilonewton per meter. So, kung mararecall natin sa code sa NSCP 2015, may mga parameters kasi ang bawat buckling or yung pag-collapse ng ating beam. So, kung matatandaan natin, Mn is also equal to Mp. So, kaya naging Mn is equal to Mp. Then, 25 kilonewton per meter siya. So, for the solution for the uniformly distributed load, so based on the figure, same lang naman siya ng principle sa concentrated load. Ang kaibahan lang dito is kukunin natin yung load or yung distributed load na nag-a-act sa ating structure kasi yun yung hinahanap sa ating problem na binasa natin kanina. So, we come up with this formula. So, by simplifying the formula, we will be having the answer of the load, which is W is equal to 0.16 MP. So, yung formula lang ng mga to, sinimplify lang natin para makuha natin yung pinaka-simplified answer. So, for the MP or plastic moment for this equation, di ba MP is equal to Fy dx. So, paano ba natin yan makukuha? Di ba in the problem, we have given the properties of this field which is Fy is equal to 345 megapascal. And Zx is equal to 1090 times 10 raised to 3. So MP times lang natin yung Fy and Zx is equivalent to 3,760,500 Newton millimeter or 3.760 kilonewton millimeter. So then, by substituting lang ulit yung nakuha nating MP into the answer na nakuha natin, which is W is equal to 0.16 MP, we will be having the answer of uniformly distributed load na W is equal to 0.60 kilonewton meter. So, dahil nahanap na natin yung mga hinahanap sa problem, that's it for the discussion for the sample problem for the collapse mechanism of the PURLINS. So that's all, and thank you.